Okay, it's an enclosed figure. What else? What was true about the opposite angles? They're congruent, right? What about the opposite sides? They're congruent also, right? So all those things is a parallelogram. So, draw a parallelogram. Alright, this is our parallelogram. And realistically, we should put what? Our little arrows. And then this one, we should have 2 arrows. Alright, just to show that they are parallel. Okay? When we talk about a parallelogram, if I asked you which side, and we would call this, I don't know, A, B, C, D. If I asked you what is the base of that parallelogram, what would you say? 80. Why? Because it's on the bottom, right? Would, if Aiden was looking at it at a different angle, could he say that CD is the base? He could just tip it over, basically. So any side of my parallelogram could be described as the base of my parallelogram. Would you agree with that? Okay, so from there then, we talk about the word altitude. Or bring up this word again. What was an altitude? So, a segment from a vertex to the opposite side, forming what? Perfect. Forming a 90-degree angle. So a lot of times, when we talk about altitudes here, they show altitudes by drawing them as dashed lines. Okay? And how we know this is definitely an altitude, it comes from a vertex, and it makes a 90-degree angle, like Kenzie said. Now, realize that if I'm doing this, I could sometimes do this on the outside, right? So even though that they draw this right out here, and extend this also, can I consider that an altitude of that parallelogram? Yes. Okay, so don't be shocked if they show that that altitude and that 90-degree angle is on the outside of my figure. So, if we continue on with this then, we know that if we're talking about the area of this, now we've basically, when I drew both of these altitudes, what did we essentially make? A rectangle, right? And what is the area of a rectangle? 160. No, the area. If you're going to find the area of a rectangle, how would you find that? Length times width, right? Because we always know that they're straight. Well, now, instead of calling the width, we're going to call it a height. And what it's sitting on is my base. So the area is equal to the base times the height. Now this is where you got to start really taking into consideration and being very careful about what kind of letters you're using. Capital letters versus lowercase letters are huge in this chapter. And notice, my A is always a capital A. If it's capital, this means the area of. Okay? My lowercase letters are. This is my base. This is my height. These two together always have to form a 90-degree angle. That's how you know the two sides that you're going to use for your base and your height, which is called our altitude. So where is this going to get a little bit more complicated? Well, now we can come back and if I know that this is a right triangle, anytime that I have a right triangle from here on out, I can use what to find pieces of my right triangle? I could use the Pythagorean theorem, which is a squared plus b squared equals c squared. I always know that my c squared is always my hypotenuse, the side opposite of my box. I can use special right triangles. Remember those? What were my two special right triangles? 30, 60, 90, or 45, 45, 90. And what were the lengths of the ratios in these two? What was in the 30, 60, 90? 1 square root of 3 and what? 2. Perfect. How about for my 45, 45, 90? 1 square root of 2. Awesome. So you might use that. You might just use regular trigonometry. So if it's not one of those angles, 45, 30, or 60, then you can use regular trigonometry. And how do I remember my regular trigonometry? What's my word? SOHCAHTOA, right? The biggest thing with SOHCAHTOA is how to spell it. So, don't forget how to spell it. SOHCAHTOA. And so we might set up fractions in that sense. What are the capital letters? The capital letters are my ratios. The lowercase letters are my sides that I could use to form those ratios. All right, remember, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay? So for a parallelogram, we're going to use A equals BH, where my H is really my altitude. Good with that? So from there, then we talk about the area of a triangle. And this is probably one that you've done way more times. But what happens if I draw this kind of triangle right here? So this would be basically an obtuse triangle because this angle is obtuse. Let's call this A, B, and C. Do I have a height of this triangle right here? No, right? Remember, when I'm looking for a height also always has to be an altitude, and an altitude always has to form what? A 90-degree angle. So anytime that I have an obtuse triangle, I'm once again going to draw this, and I'm going to draw this. Now this is where the confusion kind of comes about. So again, I need that right angle to signify that this right here is my altitude. But if it's my altitude, it's going to show me my height of my triangle. And so then, if you remember the area of a triangle, what would you say for the area of any triangle? A was equal to what? Base times height divided by 2. Or sometimes they say 1/2 BH. Those two things are the exact same thing, right? If I have a 1/2 out in front or if I have it divided by 2. But notice again, my little b and my little h. This is really, really, really important when we get into the polygons. But notice here now, if we go back to this equation or this triangle, okay, obviously my altitude is going to be this side. Some people get confused that it's not a part of the triangle, so how can I use that as my altitude? That's okay, we just want to know how tall it is. We don't care if it's one of the sides. And then when I'm going to find my base, again, like Kenzie said, to me it would be the side that it's sitting on, but it doesn't have to all the time. It just has to, the base is always the side that makes that 90-degree angle. So in this case right here, if they showed you that this was 8 and this was 4, for instance, we're just saying the little piece out here from where my triangle ended to the little piece that I finished with. When I'm thinking about the base of my triangle, am I going to use 8 or am I going to use 12? What do you think? Merrick says 12. Who's with Merrick? None of you are with Merrick? Thanks, man. But you're wrong. So, here's where the key to the whole thing is. When you're doing a problem like this triangle right here, only use the part of the triangle that is actually in the triangle. And again, that's where some people get really confused. All right? So it's base times the height, but we don't include this part. Why did they give us this part? Maybe they're going to ask you to find the perimeter of the triangle, and they didn't give you the length of this side. But they gave you the height, and they gave you this. Now I can find the length of this side by doing what? Pythagorean theorem, okay? So, that brings up a question. What's the perimeter of an object? Adding up all the sides. So remember that too, and we'll go over that when we get into our examples. So, the two equations that you really need to know in this section are those two right there. Any questions with those? So we got the area of a parallelogram, and we got an area of a triangle. You will have to write all of these down on the quiz, on the test. So you need to know them. Okay? Any questions? So that basically that's section 1. If we were just doing section 1, we'd be done right now. Okay? Section 2 then, we carry on and talk about the area of a trapezoid. So, what's a trapezoid? Two sides are parallel, the other sides are what? Not. Okay. So, basically, a lot of the time when somebody says a trapezoid, we think of this. Right? So, as Bo said, two sides are parallel, so we can come back and put our little arrows here. The one that gets a lot of people is this shape right here. Is that a trapezoid?
Yeah.
Yeah. Even though that they have this box here, for whatever reason, a lot of people don't think that's a trapezoid, but it is. Okay? So again now, we're concentrating on finding an altitude. So again, if it's an altitude, it's got to start at what? One of the vertices, and it has to go down and make a 90-degree angle, right? So, when we're talking about altitudes, we're dropping this line down here again and making sure that I have a box. In my second example of a trapezoid, my altitude, though, is actually the one side of the trapezoid, because it made that 90-degree angle, right? So just remember that. So, other things that could happen in a shape like this trapezoid, you can have an isosceles trapezoid. And if it's isosceles, what's that mean? Two of the sides are congruent, right? So if this is an isosceles trapezoid, and if I would really want to make this, I'd have to, looks like, extend this way. I don't know if that was any better. But an isosceles trapezoid would look like that. And again, the only thing that concerns us there is that our sides are congruent then. Okay? So basically, if you think about this, if I drew another altitude right here, what would I have as my shapes? I'd have two triangles and a square, maybe a square, but definitely a what? A rectangle, right? So realistically, if you forget the area of a trapezoid, you could make these shapes right here and try to figure it out by splitting it up into the shapes that you already knew. That make sense? All right? But if you can't remember it, we might as well remember the new formula. So, as we still have capital A, and as Bo said, the two sides that are opposite of each other that are parallel, a lot of the times we call them what? The bases, because again, it looks like they're sitting on them. So we're going to have B1 and B2. Just simply means B, base 1 and base 2. We're going to add them together. and we're going to divide by 2. Now, again, a lot of the times you might see this. Those two things or formulas are exactly the same thing. So again, where are we going to run into, I guess, more advanced stuff is maybe they don't give us this altitude and they want us to find that altitude. So we, again, would come back and use our special right triangles or our trigonometry. And again, we'll show you all that here at the end when we go through examples. All right, so another formula. So today we've gotten 3 formulas so far, and we're going to do one more. Any questions with this one? So the last thing that we're going to talk about is, well, there's actually 2 things, but we're going to wrap it into one. A rhombus and a kite. What was true about a rhombus? All the sides were congruent. What else? It essentially was a what, though? It was a parallelogram. Okay? All we did with the parallelogram to make it into a rhombus was make the sides all congruent. But when we did this, what else did we do? So we'd have our little marks here. Do you remember anything else that was important about a rhombus? When I drew these diagonals, what happened? Remember?
Bisected the angles.
The angles bisected. Perfect. What else? What happened at my intersection of my diagonals in the middle there? They made 90-degree angles, so we could put a box there. So realistically, when I drew one of those diagonals, what did I split my rhombus into?
4.
Okay, 2 triangles at the beginning, and then when I drew my other, I made it into 4 right triangles. But this second diagonal, if I drew this diagonal right here first, this second diagonal could actually act as a what? As the altitude of that first triangle, right? Everybody see that? This diagonal acts as the altitude of this triangle when I drew that first diagonal. So essentially, we made 2 triangles that were exactly the same. Would you agree with that? Okay? Now, what's a kite? Okay, so those drawn this. What was the definition of a kite? Do you remember? Consecutive, 2 sets of consecutive sides that were congruent, right? So this was congruent to this. This was congruent to that. And then the angles that were opposite of each other were what? Congruent. Okay? So, we are going to again draw the diagonals. And what happened with the diagonals of a kite? They made a right angle too. Obviously, they're not congruent the same way as the other one in a rhombus, but essentially we're going to use the same concept because of the 90-degree angle. And again, notice this triangle and this triangle, would they be congruent to each other? Yes, and this triangle right here and this triangle right here, congruent to each other. So we have 2 sets of congruent triangles because of the diagonals, and the diagonals making a base and a height. So the area of either one of these, a rhombus or a kite, is D1, D2, which obviously just means what? Diagonal 1, diagonal 2, doesn't matter which one's which. Heck no. Okay? But notice the difference here. In a trapezoid, we added them together. In a kite or a rhombus, we multiply them together. And then we are going to divide by 2. And again, if you wanted to write it as this, totally fine. Right? Some people like the 1/2, some people like to divide or think about it as divided by 2. Essentially, it's the exact same thing. And again, where are we going to think about some of this stuff? It comes back, and we're going to use trigonometry, we're going to use special right triangles, and just to take it that step further. And so, again, this is important. 1, 2, 3, and 4. The biggest thing is capital letters versus lowercase letters. Notice, the only thing that's a capital letter today is the A. The area is capital letter. Everything else is a lowercase letter. I know you don't think it's significant, but it will be counted wrong when you write these down. All right, so you got to have all lowercase letters. And again, here, B1 and B2, it doesn't matter if B1's on the top or B1's on the bottom. Diagonals, it doesn't matter if this is D1 or if this is D1. Those are interchangeable, because essentially you're going to do them the same way anyway. Okay? Questions here? All right, so let's go and look at some examples. And then, like I said, you'll have all day tomorrow to work on the problems in class. Nope. So, here's my first problem. Again, make sure that you read the directions. Okay? This one says find the perimeter and the area. Here's the other thing. Sorry, I forgot to say this again. If I'm finding the area of something, my answer has to be what? It has to be squared. Area is always squared whatever. So don't forget that. That's huge too. Especially in a problem like this when it asks for the perimeter and the area. My perimeter, the answer is what? Just whatever they ask me of, right? Because all I'm doing is adding up the same kind of thing. And area is squared because I'm multiplying two things together. Inches times inches make it inches squared, and so on and so forth. Good to go? All right, so find the perimeter and the area of RSTU. Do we have enough information here? We do. Can I find the area of that parallelogram with what's given to me in this picture? Do I know what that dashed line is? We can find it, but we don't know it right off the hand, right? The information that's given to us. So, realize, because what I think Merrick said, the opposite sides are also congruent. This over here is 20 also. This is where it's really important that you realize that this 12 is just this section right there. It's not the whole side, because the whole side's how much? 32, right? 32 is also down over here. So we know that if you really wanted to, we could figure out the length from here to here, right? But that's not important. So I need to know this pink line though. How do I find the pink line? What? We're going to do Pythagorean theorem, right? What is my A? 12. That's fine. What is B? B, I don't know, right? And my C is obviously my 20 in squared. Now, why am I doing this? Because I need the height for the what? For the area. Do I have enough information to do the perimeter right now? Yeah. The perimeter is what? 32 times 2, 20 times 2. So we'd add that up and put inches on it. So, if I do my Pythagorean theorem, what's 400 minus 144? 256, square root of 256. So B is 16. So if B is 16, what am I going to use for the area? What is my base and my height of this object? Where does the 90-degree angle is being made? It's right here. So I use this side and the side that makes that 90-degree angle. So what two numbers am I using for the area? 32 and 16. Exactly right. Remember, it has to make the 90-degree angle, and that's why we had to go through this to find this 16. So we're going to do 32 times 16. My answer is 512 what? Inches squared. Everybody good with all that? So, if you want to go through or see this actually all the way. There's my perimeter, as I think Kenzie said. We found our 16. And then we'd use that in our answer for 512. So you did it right. Here's a good one to do. So here's the kind of the next step of this. So right here, you find the area of my parallelogram. So what do I have to do? What do I need in order to find the area again? I need a height. Okay? So obviously, again, as somebody said, if I'm going to do this, I'm going to take my 9 and move it over to the other side. So 9 is actually here. So do I know this little piece right here? No, I don't this time. So how do I find my height? Now this is where I come back and use my trigonometry or my special right triangles. If this is 45 and this is 90, that means this right up here has to be 45. So now I have my 1 square root of 2. And it's always opposite. So this is 1, and this is the square root of 2. So what do I have to do to 9 and square root of 2 to get back to one of these sides? Divide it by the square root of 2, right? So I'm going to take 9 divided by the square root of 2. Essentially, for this, you could just punch this into your calculator. Because it doesn't really matter if you have a decimal answer. Now, if you're going to use the decimal answer and use 9 divided by the square root of 2, whatever you get in your calculator, do not round it. Use that entire number, and then I'm going to use that and multiply by what? To find the area. What? By the base, which is 12. I'm going to use that number times 12. Everybody good? Seems like we're kind of half out of it again. So then we look at triangles. This is a pretty good problem right here. You need to buy enough boards to make the frame of the triangular sandbox shown and enough sand to fill it in. If one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and how many bags do you need to buy? So essentially, this is 2 different problems in one problem. The board part of it essentially revolves around the what of my shape? The perimeter. Exactly right. So when I'm doing the perimeter of my shape, I'm using the 3 numbers right here that they gave me. If I add those up, I get 12 plus 16 plus 7.5. I get 35.5. What do I do with that number right there? Divide by 3. Right? Because I'm looking for the number of boards that I need to make. If I divide by 3, I get 11.8. So how many boards do I need? 12. I got to round up. Okay? Now, how do I find out my area of my triangle? 12 times what? 9 divided by 2. So I get 54. And what do I have to do with my 54? Divide by 9. So I get how many bags of sand? 6. Okay? So it's kind of a really good problem. It made you think a little bit, but it used everything that we had talked about. Last one, I believe, is this one, for this section. The height of a triangle is 12 inches more than its base. The area of the triangle is 560 square inches. Find the base and the height. How the heck do you do this one? If I'm going to do this one right here, I'm going to say that x equals my base. It really doesn't matter which one I do this to. I could make x my height, but I'm going to make it my base. So my height then is represented as what? How would I represent my height if my base is x? X plus 12. And now what do I do with those two things to find the area of the triangle? Multiply them. X times x plus 12 is equal to what? 560? But is that all I have to do? What kind of shape is it? It's a triangle, so I need to make sure that I divide by 2. Right? Base times height divided by 2 is my area. So how would I solve this? I'm going to multiply by 2. So I get 1120. I'm going to distribute here. X squared plus 12x. And then I'm going to bring everything to one side. And now I have 2 options to solve this. What are my 2 options? Quadratic formula or factoring. Now I actually went through and factored it, but it took me a little while to find the factors. Quadratic formula is always going to work, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So either one of those will work. And then you just find your answers. All right? The other section, I don't think as complicated. So here's my trapezoid. So do I have everything that I need? I have my 2 bases and my height, right? So I'm going to take a 3 plus 2.5 divided by 2. And basically, that one's it, right? Something's wrong here. I forgot something. No, we do need height. So, come back here. And either way, put an H up here. So it could be 1/2 base times height. Sorry. So we gotta have that height in there. Now in this one it doesn't really matter because it's 1, but you do need that height. So I forgot the H. My apologies. Okay. Alright. So here's that one right here where a lot of people don't know this. And the bad thing with this, they really should have shown your little box here. So we have to kind of assume that they wanted that box there, but this is here. And then to solve this, I would make this. And I know that this is 4. So I realistically need to find out what that is and not assume that this is a square. So if I'm going to do Pythagorean theorem, does anybody know what this side has to be if you just look at it real quick? What? It has to be 3. Or B, yes, but it has to be 3 because 3, 4, 5 always makes a Pythagorean triple. Okay, so then if this is 3, I know that this is 6. So this is 6 up here. Because they tell me that it's a trapezoid, and because they tell me a trapezoid, these have to be parallel to each other. Now I would have enough information. I'm going to take 6 plus 9 times 4 divided by 2. Okay? So that was kind of a good problem too. And then our kites, or our rhombus. So this one, they basically don't do anything special. They just give you the 2 diagonals. And so I'm going to take 7 times 12 and divide by 2. Right? D1 times D2 divided by 2. And the same thing will happen in a rhombus. Now notice in this rhombus right here, they don't give you the full diagonals. So the first thing that you have to do is what in this problem? you gotta take each of those individual numbers and double them. So I gotta take 9 times 2 because this diagonal has to be 18, and 10 times 2, so this has to be 20. And I'm gonna take 20 times 18, and then divide by 2. So don't fall in the trap just because they give you these two numbers and take 9 times 10. Okay? You guys are killing me today. So here's a little chart, which is good. This is a note in your book somewhere. But if you wanted to look at that chart, you can easily look at that chart. All right. So the assignments will be up on the board and with the whoever the sub is tomorrow. You get the entire time to work on your assignments. Here's your test from the other day.